Hello student, hi, good evening. So today we are going to discuss about the conservative field. Okay. So what is conservative field? Okay. So electrostatic conservative field. Okay. So let us see here conservative field. Conser conservative conservative field. Okay. Conservative field. So electrostatic conservative field. Okay. So what exactly the conservative field is there? Conservative something that the field, the force. Okay. So it is a type of force. It is a type of electric force. Okay. So and other type of forces. So the forces. So it is a conservative force, it is a force. Okay, conservative field is a, actually it is a, this field is a electrostatic field. Okay, electrostatic field, conservative field means electrostatic field. If we apply the force to some particular, if we apply the force to the particle. Okay, so when we apply the force to the particle. Okay, so let us say here I am applying some force to a some particular, like if I have one particle here, if I will apply the force here. Okay, if by applying the force to this particle. Okay, so this will move to somewhere here, some other point. Okay, so now see, when we apply the force, when the force is applied on this particle, that force, the work done in moving this particle from here to here. This is my position A and this is my position B. Okay, so it depends only it depends only on initial and final position. Okay, so it does not depend on whatever the path you choose. Okay, so for from which path you are coming. Okay, so you are coming, it does not depend at all on this. Okay, so in this path, whether you are coming from here, whether you are coming from this path, but it depends only on what initial and final position of this particle. Okay, so that is what, when you apply the force to a particle. Okay, so then it only depends on, okay, so where you want to move. Okay, so let us say in this position B. Okay, so then this what work done, then the work done, whatever the work done is there to move this charge from here to here in this position B, from A to B, it depends on your initial and final position, but does not depend on what other path. Okay, so that is what about conservative field means. Your field has been conserved means conserved means what exactly means the conservative means, this is what kinetic energy. Okay, so there is no change in the kinetic energy if this particle is there. Okay, so if this particle is there, now this particle will reach to this position B. Okay, so it will start from position A and it will reach to this position B, and automatically if this particle automatically come back to its initial position. Okay, after moving this, come back to its initial position, that time the kinetic energy this particle have what same kinetic energy as this particle had initial. Okay, so you understood what exactly means that if we apply the force to a particle, then after completing the round trip. Okay, so after completing after after reaching the final position, when it will round back. Okay, so when it will come back to its initial position, that time if the kinetic energy is same, okay, same as that of the kinetic energy that it had initially. Okay, it had initially, like this is particle P1. Okay, so this is my P1 particle. Okay, so it has kinetic energy, like say the kinetic energy is E1. Okay, so this is what, like kinetic energy KE1. So particle P1. Okay, so when it will move to this position B. Okay, this position B, when it will come back to its initial position with the same kinetic energy, K1, Ke1. So then that means what? That means the force. That means the field is conservative. Field is conservative. Okay. So field is conservative. So this is what conservative field. Conservative field. If you see here, in case of like gravitational field. Okay. So gravitational field. Let us say like gravitational field. In gravitational field, what is there? If you see, this is on the from the surface of the earth. If you will what, throw some object. If you will throw some object at particular height h, it will go by which work? As we know very well, work done is equal to W is equal to FD S. Okay, FDS. So this is what force into distance. What is force when it is moving upward? What is the force? Is nothing but mg. What is ds? Distance, how much? H, mg h. Okay, so then it will automatically come down by gravitational force of attraction. Okay, gravitational force of attraction, it will come by same work done. Okay, so this is also what? Mgh. This is also mgh. When it will come down. Okay, when it will come, it will go up when you will throw some object. Okay, from the surface of the earth, it will go with the work done of FDS, which is nothing but mgh. Okay, it will come down automatically. Why? Because of gravity. So if you see here, the kinetic energy change in the kinetic energy is what? Zero. Okay, so whatever the kinetic energy that object has, when you will throw it up. Okay, so that time the kinetic energy is ke1. And when this object will come down with the because of gravity. Okay, so then that time also the kinetic energy is what? Ke1. So what we can say here, the kinetic energy, change in the kinetic energy is zero. Means the kinetic energy is totally conserved. Okay, so in this way we can say that it is a conservative field. Like in elastic, if you see elastic force, like let us say the example of like a spring. Okay, so when you will stretch this spring. Okay, so from one position, if you will stretch this signal, this spring, somewhat like this. Okay, so it will go some position, like it will stretch like this, and it will come back to its initial position. Okay, as you will stretch it, then after that it will come automatically to its initial position. And here, if you will see when you will stretch it, means you are applying some force, and that time its kinetic energy is what? Ke1. Okay, so let us say you have stretched it with this kinetic energy Ke1. Okay, so whatever the work done is there, then after that it will come. Okay, it will come back to its initial stage with the same kinetic energy Ke1. With the same kinetic energy Ke1, it will come back. Okay, so in its final initial position. Okay, so that time also this, you are just stretching this spring. Okay, so with the kinetic energy K1, and when you will left it back, then this spring will automatically come to its initial position with kinetic energy K1. So now see here, in case of elastic. Okay, elastic force. Yes, in case of elastic force, like stretching the spring, here the kinetic energy, change in the kinetic energy is what? Zero. So this means kinetic energy is totally conserved. In gravitational force also, when you will throw a object up. Okay, from the surface of the earth, it will go with the kinetic energy Ke1. Okay, so then due to the gravity, this object will automatically come down to the surface of the earth with the kinetic energy Ke1. Means there is no change in the kinetic energy. So means here kinetic energy is totally conserved. So therefore these are conservative field: gravitational field, electrostatic field, and elastic force of attraction. So these forces are what? Conservative forces. Okay, conservative field means what? Electric field, magnetic field means what? If you will see some charge, if there is some charge, okay, q, then there surrounding this there will be what, some field. Okay, so some field will get established around this charge. Wherever you will get the charge around this, surrounding this, you will get what, electric field. Electric field. Okay, so electric field. So these are what, conservative field. Conservative field. Electrostatic field is a conservative field. Whatever the force you will see naturally, these are what, these are conservative field. So whatever the force that you apply manually, okay, so like normal force, frictional force, all these forces are non-conservative field, non-conservative forces. Okay, so here work will depends, whatever the work you will do to move some particle, whatever the work you will do to move some object. Okay, so from some position to some other position. So that time when that time what happened, the kinetic energy, when that object will come to its if its initial position, so the kinetic energy that the particle or the object held object have, if it is not similar to the kinetic energy that it had initially, then in that case we can say that the field is not conservative or force is not conservative at all. Okay, so this is what about conservative field. And if you see, in case of what, in case of electrostatic field, integration E vector dot dl is equal to what, 0. Integration E vector dot dl is equal to 0. Closed integral E vector dot dl is equal to 0. Means here from path A to path B. Okay, so if you see, the closed line integral is equal to 0, and you can see del cross E is equal to what, 0. From here we can see that what, the electrostatic field is a conservative field. Electrostatic field is a conservative field. So now how we can prove this, that electrostatic field is a conservative field. So let's see. If you will see how the electrostatic field is a conservative field. Conservative field. See, first of all, what is electric field? What is electric field? Electric field. Yes, electric field. What is this electric field? So electric field is nothing but, if you see, the electric field is nothing but force per unit charge. What? Force per unit charge. Yes, force per unit charge. As we know what force. Force means what? Between what? Force between what? Force between particle. Particle means charge. Positively charged particle. If there is a force exists between the two charged particles, that is nothing but q square by 4 pi epsilon r square, epsilon r square. So there this force per unit charge will give us what? Electric field. Electric field. Okay, so in the direction of, in the radial direction, because radial means what, wherever the charge is there. Okay, so if the charge is there, so the field that can established around surrounding of that charge at anywhere. Okay, so from that point of view we can say that the field that can establish at any point surrounding the charge. Okay, so that's why we are taking what, we are taking the radial direction. So this is nothing but q by 4 pi epsilon r. Q by 4 pi epsilon r, a unit vector r. This is the direction of what? Direction of electric force. Yes, electric force direction. Okay, so this is what electric field. Force per unit charge. Force per unit charge. Now see the close. This is what line integral E vector dot dl. E vector dot dl. Okay, so this is what line integral E vector dot dl. So what is dl? Let's say there is a charge. Positive charge. Okay, so positive charge. Due to this charge, so there is establishment of what electric field. Let's say electric field is established at point A and at point B. Okay, so at point B. So let's say this is the distance. What? This is a distance RA. And this is a distance RB. So now see, it does not depend at all at to through which path you are going. Whether you are going from this path, whether you are going from this path. So it does not matter at all, and it will depends only on its initial and final position. See here, initial and final position. If you will see from here, so this is E vector dot dl, line integral, line integral. So now let's say, so this is line integral, okay, E vector dot dl. If you will solve this like from between path between a b to a, okay, so b to a. So let's say this is what integration we are doing integration from path, let's say path b to a, what is electric field? If you see, the electric field is nothing but q by 4 pi epsilon, what r square, okay. So this is what a unit vector r, r. dl is what? Radial direction. Let's say this is what we are taking a small length, that is dl, okay. So dl, differential length. So dl, so this dl is nothing but, if you see here, dl is nothing but dr a unit vector r. So this is what dr a unit vector r. Yes, as you know very well, a unit vector r is nothing but unity, 1. Yes, so this is what b to what a, b to a q by 4 pi, epsilon r square dr. So this is what E vector dot dl. This is actually what, this is my work done for what? To move the charge from one place to other place, okay. So this is what ultimately, this is what work, okay, so that we are doing. So this is what work done. So if you see integration, so let's say take this 4 pi q by 4 pi, epsilon outside, and integration is what? Integration for b to a, integration b to a. So this is what? Dr divided by what? R square. So now integrate this, what you will get? You will get 1 by r square. Integration is nothing but minus 1 by r, just put the limit. What is this? b to a. So now see here, b to a, and this is what? Q by 4 pi, epsilon, okay. So now q by 4 pi, epsilon minus upper limit r a. So let's say this is a minus plus. So this is 1 by b. So this is what we got. E vector dot dl, dl integration is equal to what? Is equal to q by 4 pi, epsilon, this is 1 by b minus 1 by a. So if you see here, through which path you are going, okay. So through which path you are going from b to a, it does not matter at all. Why? Because as we have seen it from this integral, okay, so as we have derived and we have reached to the final solution, that is saying what? That is saying that E vector dot dl E vector dot dl is what? E vector dot dl, when you will go from what? B to A, it does not depend on what path, whatever the path you will choose, okay. So it will depends only on what? It will depends only on initial and final path. So from here it is clear that what we can say, that E vector dot dl is equal to q by 4 pi epsilon 1 by b minus 1 by a. So b and a are what? Distance from what? Charge, okay, from charge. So let's say this is what ra, distance, sorry, this is what? Distance rb. So ra, this is rb, this is ra, this is rb, this is ra, and this is rb, and this is ra. So rb minus ra, distance, okay. So distance. So from here now we are very much confirmed about conservative field, that whenever we apply the force, to a particle from moving from one position to other position, it does depend only on what? Only on initial and final position, okay, and it does not depend at all other path, okay. So these are what? Conservative field. So and And if we see, now we can say from here what closed line integral from b to a, from b to a, e vector dot dl, e vector dot dl, it, okay, so e vector dot dl, so this is what 0, and del cross e is equal to what 0, del cross e is equal to 0. Okay, so that is what we have seen. If you see what closed line integral, okay, so here we are just doing for open integral from b to a, from b to a, from b to a, only from b to, this is not closed, this is open. Okay, open integral. Okay, in open integral it depends on your initial and final. If you see closed path, if you see closed path, first from b to a, first from b to a, and then from a to b, first b to a, then b to a, then first from b to a, then it will come back. Okay, so now see the question is about a field. Okay, so a vector field is given, a vector field is given. Okay, so vector field is given which is conservative field, and this vector field is conservative field, and is asking what is the scalar potential, what is scalar potential. Okay, so he's asking about what is the scalar potential. Now as we know very well, what for conservative field, it is given that the field or the force F is what is, this is conservative. Conservative means del cross F is equal to what 0, del cross F must be equal to what 0. Okay, so it must be equal to 0. For that as we know very well, del cross F is equal to what, del cross F is nothing but equal to what, equal to ix, or I can say a unit vector x, a unit vector y, a unit vector z. Yes, this is dou y, dou x, dou y, dou y, and here it is dou y, dou z, dou y, dou z. So this is given as, if you see, this is fx, here it will come fx, fy, and fz. What is fx? Right from here, what is fx? Y square cos x, y square cos x, plus a z square. Okay, a z square. And what is y? A unit vector. What is fy? Fy is nothing but 2y. So 2y sine 2y sine x minus 4 sin x minus 4. And what is fz? So this is 3x z square plus 2. So let me write this here properly. So this is in the position of what, dou by dou x. So this is dou by dou x, dou by dou y, and this is dou by dou z. Yes, dou by dou z. So when we solve this, what we will get here, del cross f vector is equal to what? This is dou by dou y. Okay, so dou by dou y. So just solve this, what we will get here. So this is 3x z square. So dou by dou y. So there is no function of y. So it is 0 minus this dou by dou z. Here also no function of z. It is also 0. So first is what? First we can say it is 0, a unit vector x. Okay, so next is what? Next is for y. So this is dou by dou x. Yes, it is a function of x. So it will come 3. It will come 3z square. Yes, 3z square plus 3z square minus it is also a function of z. So dou by dou z of what? Y square cos x plus az square. So what it will come here? Minus. So this is minus az square means 2az, a unit vector y. Okay, so now see here plus. So this is minus. Now plus dou by dou x. Yes, it is also a function of x. So it will come 2 sine 2y cos x. This is 0. So because it is a constant, and minus dou by dou y. Yes, it is also a function of y. so it will come minus 2y cos x 2y cos x plus z square, it is 0. So this is a unit vector z, a unit vector z. So now if we observe from here, what we got, del cross f, del cross f, f is equal to minus 3z, 2, you can say from here 2az minus 3z square, 3z square, and here it is a unit vector y, and this is plus 2y, 2y, sorry. Okay, so this is what del cross f is equal to 2, this is 2az z minus 3z square a unit vector y plus this is a unit vector y plus 2y 2y cos x minus 2y cos x, just a minute. So this is 2y cos x. So from here, yes, do by do x 2y cos x, just do by do x 2y cos x minus 2y cos x. Yes, it will get cancelled out. Yes, so we are only left with what? We are only left with a unit vector y quantity. Yes, a unit vector y. So now if we see from here, from option, so this is what about xz cube. So the option here that is given, so this is del cross f is equal to 0. Okay, so del cross f, so just wait. Okay, students, sorry, this is actually z cube, this is actually z cube, not z square, it is actually z cube, and this is also z cube, this is also z cube. Okay, so when you will differentiate it, it will come 3az square, it will come 3az square. So this is 3az square, 3az square minus plus, it will come 3az square, 3az square. Okay, so now as we know, this is equal to what? 0. This is equal to 0 when it is 0, this is 0 when 3az square, 3az square is equal to what? 3az square is equal to 3z square. So now if you will see from here, a is equal to what? 1. A is equal to 1. That we got a is equal to 1. Yes, if you will observe what option, if we will observe option number B is here, where if you see the coefficient of z cube. Yes, option number B is that, because option number B, why I am saying that, because he is asking about what? Vector. He is asking about scalar potential, because potential is automatically, it's a scalar, okay, scalar quantity. And why we choose option B? Because as option B is given as xz cube. Okay, so let's say v is equal to, if we choose option B, so option B, the B is equal to x z square xz cube, okay, xz cube plus y square minus 4y y plus 2z. As we know what? As we know that v, so f is equal to what? F is equal to del v. Yes, as we know that what? Electric field is equal to what? Minus del v. Yes, minus del v. From here, electric field, that is electric force, F is equal to minus del v. Okay, so when we differentiate this del is what? Del is dou by dou x, a unit vector x. Okay, so a unit vector x. So let's say solve this potential, for this potential fx. When we solve for fx, so this will come ZQ. Yes. So just when you will solve this fx, okay. So because we are just calculating fx is nothing but, which is nothing but, if you see fx is do by, fx is do by, so this is e is equal to del v. Yes, f is equal to del v. So this is fx is equal to do by do x, do x, f do by do x of v. So v do by do x of v a unit vector x. If we will solve this, what we will get here, this is zq plus, so zq plus, so this is given, and this is given as y square sin x. So this is sin x, okay. So this is y square sin x minus 4y plus 2z 2z. When we will solve this, we will get fx is equal to zq plus y square cos x. Yes, now you just compare this, you just compare with this, okay. So this conservative field, okay. So this is my fx, this is my fx, this is my fy, and this is my fz. If you see, if you will observe this fx and fx, both are same, both are equal when a is equal to 1, a is equal to 1. Yes, a is equal to what, here 1, here also a is equal to 1, and hence we can say that option b is correct. For this, option number b is correct, okay. So this is all about, this is all about this question, okay. So this is also related to what, conservative field. Conservative field is given, means conservative means what, del cross f is equal to 0, okay. So where we have to find what, scalar potential. For this we have seen, and hence the option b is correct, okay. So that's all for today, okay. So we have seen total concept about conservative field, okay. So how the conservative field is there, what is conservative field, and what is non conservative field, okay. So that's all for today. So thank you very much to